Plant Care articles: a deeper look into fertilizer measurement. Here at Easy Bloom, we truly appreciate customers like you and carefully consider all comments and feedback you send our way. Some of the recent commentary has been concerning how the PlantSmart plant sensor is capable of sensing the amount of fertilizer in a soil and asking for tips and hints about fertilizer. These are fairly involved questions/comments deserving of more involved answers, which is why I, Dr. Robbie, wrote this article. I would like to share some of insight on how PlantSmart can measure fertilizer and why our science team made the decisions we did when engineering PlantSmart. Enlightening you with some of the science behind PlantSmart will also make it easier to understand some of the techniques that will make your user experience even better. Additionally, this article will go into more depth than another one I wrote, Why Do I Need to Fertilize My Plants?, which discusses what plant fertilizers are and what they do for the plant. I would like to expand upon that article a bit. So what exactly does PlantSmart measure? PlantSmart measures fertilizer. Done. Next question points right? Well, it's more involved than that. When engineering this new sensor, we did not try to reinvent the wheel, but the wheel we ended up with is extra fancy, more on that later. Measuring fertility in the soil has been around for a long time. The way scientists monitor soil fertility is by measuring what is called the electrical conductivity of the soil, aka, the EC. But why is EC important? Every nutrient that a plant can absorb from the soil must be dissolved in the water that is in the soil matrix. Also, practically every one of these nutrients is dissolved as a salt in the water. When a molecule of salt dissolves in water, it falls apart into two constituents, and each part of the original molecule has either a positive or negative charge on it. This is good news. Scientists have developed a way to monitor those charged molecules. As the concentration of salts increases in a solution, electrons can be conducted across it more easily. In other words, that solution's conductivity has increased, and that, along with the conductivity of the solid soil particles, is exactly what is measured. Measuring the EC of a soil involves measuring both the solid and liquid portion. PlantSmart follows this same model when measuring how much fertilizer is in a soil. Measuring EC is an easy, robust way of monitoring the overall fertility of the soil. However, there is a fundamental problem with measuring the EC of both the solid soil particles and the nutrient solution in between the soil particles in a soil matrix. Remember what I wrote earlier? Nutrients must be dissolved in water for a plant to absorb them into the roots. In other words, only the liquid portion of the EC measurement is pertinent to the plant. Luckily, science has provided another solution to this problem. If you know a couple of commonly measured environmental conditions and the EC of the soil, you can calculate what the EC of the liquid portion of the soil is. This is the step that most store-bought fertilizer sensors skip, usually, because these devices cannot perform the math to calculate the EC of the liquid portion. PlantSmart, on the other hand, calculates the liquid fertilizer concentration to provide you with the best information concerning fertilizing your plants. There is another reason why, when we designed this new sensor, we wanted to calculate the liquid EC. Customers who use PlantSmart can monitor the fertility of the soil for any of the over 6,000 plants in the Easy Bloom plant library. If you were to monitor a gardenia, then PlantSmart would use the cultivation needs for fertilizer that are specific to that gardenia. When scientists originally researched the cultivation needs for all of these plants, they always refer to the liquid fertilizer concentration. So once again, PlantSmart specifically monitors each individual plant with scientific information that is pertinent to the health of the plant. The importance of fertilizer. Plant fertilizers are often called plant food, but this isn't exactly accurate. Plants make their own food from sunshine, air and water. It would be more accurate to call plant fertilizers plant vitamins. Much like how the vitamins that we take make us healthy, plant fertilizers improve the overall health of the plant. This means the plants will grow more roots, stems, leaves, flowers, fruits and seeds. Knowing that, one might ask, why would I need a sensor to tell me how much fertilizer is available for my plants? Fertilizer is good for plants, so I will just give my plants as much fertilizer as possible. Once again, plant health has a parallel with human health. Just like us, it is possible to have too many vitamins. Too much fertilizer will kill off a plant much quicker than too little fertilizer will. In response to this physiological aspect of plants, we designed PlantSmart to also warn our customers if there is too much fertilizer. When there is too much fertilizer in the soil, the plant's roots cannot absorb water as easily. Plants often play by the same rules that we people have to play by. Yet again, we have another analogy to human physiology. When it comes to salt, eating too many salty snacks causes us to retain water. Now think of the soil as having too many salty snacks, aka fertilizers. The soil is going to retain that water, and the plants are not going to be able to absorb as much of it. This can be a big problem if the weather is hot and dry. The soil could be completely soaked with salty water, and yet the plant could be wilting from not having enough water being drawn up from the roots. Another symptom of too much fertilizer, this is also known as salt toxicity, is what happens when the plant is able to absorb the nutrients but has no place to put them. A plant displaying such a symptom will have leaves whose edges are browning and dying off. This is especially true when the nutrient in question is one that is not especially mobile in the plant. In other words, once the plant absorbs it, the plant cannot relocate the nutrient. This makes sense when you think about it. Imagine an ion of calcium, Ca2+, that was absorbed from the soil, as it travels through the roots, up the stem and then into the leaf. As that ion travels up the plant, it is looking for a place to stay in any one of the millions of plant cells it passes along the way to the leaf. If there is no vacancy in any of the cells it passes, it just keeps on going, until it reaches the edge of the leaf. Now imagine the amount of calcium ions that accumulate along the edges of the leaves, because there are so many of them coming up from the roots and the plant cannot grow new cells fast enough to house them. Eventually there would be an accumulation of calcium ions along the margins of the leaves until the leaf margins start dying. Plants have different tolerances for the amount of fertilizer they can handle. For example, there are some species that naturally grow in brackish waters that can't seemingly deal with any amount of salt. On the other hand, carnivorous plants such as the Venus flytrap cannot handle much of any nutrition in the soil. This is where PlantSmart and the Easy Bloom plant library excel. Each plant is tuned to their own individual fertilizer needs. PlantSmart not only will warn you if there is too much fertilizer in the soil, but it also will inform you what the necessary actions are to remedy the problem. If you were a bit overzealous with the fertilizer recently and your plants are starting to wilt or the edges of the leaves are starting to die off, it's not too late. You can leach, or flush, the soil with water. Basically what you end up doing is washing away the excess salts. It is possible to flush too much, though, which would result in nutrient-deficient soil. It's always a safe bet to follow the instructions on whichever fertilizer you are using. Issues with fertilizers in soil. In graduate school my research was focused on plant physiology primarily in the root zone. I was interested in the interactions between the roots and the environment. Almost all of my research was done in hydroponics. This means that the plants were grown without the use of soil. For one fundamental reason, the inclusion of a solid growing medium such as soil or even potting mix introduces a lot of variability into the experiments. Unless you are growing in hydroponics as well, your root zone will have a lot of variables that can seemingly inexplicably affect the outcome of your plant's development. This is especially true, since each soil or potting mix is going to have different capacities for storing water and nutrients, which will affect how often you fertilize or water. If your goal is to grow the best veggies you can, I would strongly recommend monitoring your plants over and over again, and this especially applies to monitoring the amount of fertilizer. Imagine that it is springtime, and you have tomatoes growing. Early on in their growth, you fertilize the soil and probably expect it to last a long time. That little boost of soil fertility in combination with warming temperatures could have spurred a growth spurt. Your tomatoes develop new roots to absorb all the nutrients and new shoots for a place to store/use those nutrients. Very quickly all of those nutrients have been absorbed, and now the plant is deprived of nutrients, while you wait for the next time to fertilize. This is why it is best to constantly monitor your soil. You can catch a possible problem much earlier. The wasted time, where your plant is going without much nutrition, can now be productive time, where your plant is focusing on making tasty tomatoes.